Alright, this is the practice chapter 11 test, and as always, I am the amazing Mr. Jansen. So here we go. If we take a look at the first one, it says find the next four terms of the arithmetic sequence. Remember, arithmetic sequences change by adding something each time. So to get from one term to the next term, we're adding a negative 4. So we add a negative 4, so we're going to add another negative 4. So that's going to leave us with a 9. If we add another negative 4, we'll be at 5. Another negative 4 will be at 1. And then another negative 4, we're at negative 3. So our next four terms are 9, 5, 1, and negative 3. All right. The next one, we want to find the 13th term. This word first shouldn't be in there, but we talked about that in class. If I want to find the 13th term, that means I'm going to be using a sub n equals a sub 1 plus n minus 1 times d. So a sub n, I'm looking for the 13th term, so a sub 13 equals a sub 1 is 7 plus n, since we're looking for the 13th term, is 13, and my d value is 3. Now I just have to simplify this. So that's going to be 7 plus 14 times 3, 12 times 3. So that's 7 plus 36, which is going to leave me with a 43. All right. For the next one, it says find the four arithmetic means between negative 6 and 9. If I want to find the four arithmetic means, that means that there are going to be four terms in between those two terms. So I'm going to set it up like this with my four blanks. All right, four arithmetic means. That means this, if we label these, this would be a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So the only thing I need here is my d value in order to find all these. So I'm going to do a sub n equals a sub 1 plus n minus 1 times d. I'm going to plug in what I know. I'm going to use the 9 over here for my a sub n. So that's 9 equals a sub 1 is a negative 6 plus, if I'm using 9 for a sub n, that means my n value is 6, and then times d. Now I just need to solve for d. So I've got 9 equals negative 6 plus 5d. I've got to add 6 to each side. Divide each side by 5. And we find out that d equals 3. But I'm not finished. Since I know d equals 3, that's the thing that I'm adding each time. So I've actually got to add it. So it's going to be a negative 3, 0, 3, 6. If I add it one more time, it does bring me back to the 9. So that's my check. All right? So my answers for this one were negative 3, 0, 3, and 6. All right? For the next one, we're finding S sub n. So since this has a d value in it, I know it's an arithmetic sum. So an arithmetic series. So that's S sub n equals n divided by 2 times a sub 1 plus a sub n. So that means I have a sub n equals, well, really, I know the n value, so I could write this as S sub 20 equals 20 over 2 times a sub 1, which is 7, plus a sub n. Now, since I don't have a sub n here, I have to find a sub n. So a sub n equals a sub 1 plus n minus 1 times d. So that's going to be 7 plus 20 minus 1 times d, which is going to be 7 plus 19 times 11, which is going to give me 7 plus 209, which is going to be a 216. So that means this is going to be a 216. So I need to simplify this, so that's 10 times 223, which is going to be 2,230. And that's it. For the next one, it says to find the sum of the arithmetic series. So once again, I'm finding the sum, so that's S sub n equals n divided by 2 times a sub 1 plus a sub n. So S sub n equals, I don't know what n is, so I'm going to leave it as n. A sub 1 is 13. And then a sub n, I'm going to use this value that's out here, which is the negative 25. But the problem here is I need to find n. So once again, I'm going to use my a sub n equals a sub 1 plus n minus 1 times d. A sub n is the negative 25. A sub 1 is 13. N is what I'm looking for. And d this time is going to be a negative 2. So now I have to solve for n, so I'm going to distribute the negative 2. So that's negative negative 25 equals 13 minus 2n plus 2. Combine like terms. Subtract the 15 from each side. So that gives us a negative 40 equals a negative 2n. Divide each side by a negative 2. And we find out that 20 equals n, or n equals 20. So if I come back over here, I'm looking for s sub 20. My n value is 20. And now I just need to simplify this. So that's going to be 10 times a negative 12, which is a negative 120. All right, and that's all there is to it. If I take a look at the next one, this is my sigma notation. Remember, sigma notation, this is my starting value, this is my ending value. So that means I'm going to plug a 1 in for n, so I'm going to have 2 times 1 minus 9. Then I'm going to plug a 2 in, then a 3, then a 4, and lastly I'm going to plug in a 5, and then I'm going to add all these things together. Alright, so I've got 2 minus 9 plus 4 minus 9 plus 6 minus 9 plus 8 minus 9 plus 10 minus 9. Alright, and this we can just plug into our calculators. You can combine like terms. We'll combine some like terms here. So that's negative 7 minus 5 minus 3 minus 1 plus 1. So that's going to be a negative 15. All right. If we take a look at the next one, it says find the next two terms in the sequence. So if I want to find the next two terms in the sequence, if I look at this, first thing I have to determine is what kind of sequence this is. If we look at this one, the change here, the difference between these two, is a negative 6, but the difference between these two is not a negative 6, so it's not arithmetic, so it's probably going to be geometric. So to find out what we're multiplying by, we're going to do the 4 divided by 10, which of course is 2/5. So if I check this, it means 10 times 2/5 is going to give me a 4. And then I would do 4 times 2/5, which gives me an 8/5. So the thing I'm multiplying by is the 2/5. So I have to multiply by another 2/5. And that's going to give me 16 over 25. Then multiply by a 2/5 again. And that's going to give me a 32 over 125. And it only asks for the next two terms, so that's it. So 16 over 25 and 32 over 125.